Hello and welcome to this evening's webinar, Probability for the Normal and the Non-Normal. A lot to get through this evening. We do have a lot of people online for the webinar as well, so great to see so much interest. My name is Brian Lannon. I am your host for this evening and also co-presenter for this event. Our other presenter is Stephen Crouch from Frankston High School, and you can read Stephen's bio there. He has experience not just in mathematics but also physics and astrophysics, and teaches senior courses at Frankston High. He has conducted webinars before for T-Cubed and done an excellent job, and it's been great planning with Stephen for this evening's event. So Stephen,
Yeah, hello Brian. Hello everyone. Thank you for tuning in.
very good. Okay, and you've been hearing me okay, Stephen?
Yes, all good to go. We're going to have a very fruitful evening ahead of probability. Hopefully everyone has a good time. I'm looking forward to kicking things off, Brian.
Great, let's go. You will have read from the webinar description that we're actually quite ambitious in what we're hoping to get through this evening. We've got discrete and continuous distributions mentioned. We also mentioned both maths methods and specialist maths, and statistics of central tendency and spread, and then to top it all off, three different calculator platforms. The TI-84, some Victorian teachers may remember using the TI-84 and TI-83 platform, and now I've moved on to the TI-Nspire CX CAS. There is also a non-CAS version of that calculator, which I know is popular in some other states of Australia. We will show some comparisons between these. So just to kick us off then for our ambitious webinar, a combinatorics problem. You can see if Stephen and Brian are presented a webinar addressing two main statistics of two types of probability distributions from two different mathematics courses, and showed this on three calculator platforms. How long before everyone falls asleep? Okay, this is what the three calculators look like side by side. On the left here, if the last you ever saw of a TI-84 was or TI-84Plus or TI-84Plus Silver, it is now ramped up into a CX version. You see the colour screen, the high-def colour screen, similar to what you may be familiar with if you're using TI-Nspire, CAS or non-CAS. The other two, side by side, look very, very similar. The easiest way to recognise the non-CAS platform is if the person who put it into a package put non-CAS on that package. There are also some other hints. You see the white buttons here as opposed to grey for the numerical buttons, and also the variables X, Y, Z. The keypad here is for writing notes. They can't all be variables though. And also white colouring on the sides. That's on the front, but once you get into it, the menus initially look similar, but then there are some distinct variation. So to kick off in our ambitious webinar, I'm going to start by showing a statistic of measure of centre from a discrete distribution out of the methods course, and I'm going to use the TI-84 CE. So it's the cutting edge for some, it's nostalgic for others. Speaking of nostalgia, I'm hoping that this might bring up some fond memories. I used this in the commencement of this topic with my methods classes, because quite often I've had the very same students earlier on in their school life, in year 8 or year 9, and we played the Greedy Pig dice game. For those of you who haven't played it, it involves taking a normal cubic die, rolling it and banking the numbers from 2 through to 6, writing them down as you go, and looking at a cumulative total, you can say stop and accept that cumulative total at any stage and hand the die on to the next player. That is then your score to keep. However, if you are too greedy, hence the name of the game, then if a 1 is thrown, then the score for that turn reduces to 0. And on we go until the teacher says stop now, and the highest banked balance is now the winner. Okay. And why not in a Year 11 class to play it a little bit, just to remember, okay, what are we going to get? What do we expect to get when we roll a die? Well, this is the idea. We're looking at a measure of centre from the distribution, and you can see our formula here that our expectation or our measure of centre will be the sum of each value multiplied by its associated probability. That's what we get for the regular die. Here is the product of those things, and here is the sum of that third row, 3.5. So of course you expect to throw a 3.5 when you roll a die, don't you? Okay. It's not quite the same as our greedy pig. For greedy pig, we look at the numbers 2 through to 6 only and repeat that process and work out what you expect to get from the 2 to 6, bearing in mind that there's a 5 to 1 chance that you will do that, but of course there's a 1 against 5 chance that you will throw the killer number 1. I won't give too much away then how that leads to a strategy. And some people are looking at this saying, why didn't you just add up the numbers on the dice and divide by 6? The answer is because although that would have worked in this case, it's only because all the probabilities are the same. What if we had different numbers? What if we had a weighted die? So those sorts of problems are a good little introduction to our probability. I'm sure you're anxious to get more involved with the continuous distributions, which have a lot more involved, particularly in a calculus course, and even think about what that would look like for a normal distribution. Well, before we go there, consider once again our dice. Here we have the probability mass function as opposed to a probability density function, mass being for the discrete distribution, and you see the sum of all those probabilities equals 1. Of course it is 100% absolutely certain that we will get something when we roll a die. If I were to perhaps, shall we say, integrate or shade or work out the area of our rectangle here, did you like the little move to the integration sign here? I would also get 1, would I not? A rectangle of base 6 units and height 1/6.
Yeah, if I could chime in there, Brian.
Yeah.
Yeah, that was really good. I mean, if everyone could have seen, he started off with the probability mass function, which was 6 lines of equal height, and suddenly changed that to a rectangle. That showed a really good sort of movement from a discrete to a continuous, and showing what the difference between a mass and a density. So I think that's a really good point to bring up, and it's I'm glad that Brian identified that in his presentation.
Thank you. Thanks, Stephen. I'm also hoping that people liked my little graphic there, because it took me ages to do that transition of the sigma notation to the integral sign. So
we've all been there.
Okay, what if we examine the situation of 2 dice, as I'm sure you have, and you know the most frequent outcome from adding the 2 dice together will be 7, and of course less frequent for the 2 and the 12. If I took the area under this triangle here, would that also be 1. Let's have a look. Let's get a line there. Let's clip the line, and I'll just show you how I did that. There's the equation of the line. Remember the old function editor in the TI-84? And here is how I restricted the domain. Unfortunately, I have to, in that technology, use an AND statement rather than just say 1 is less than or equal to x is less than or equal to 7. But that gets us there. And I have the capacity with that technology to do a shading under the function. And from 1 through to 7, I've got the value 0.5. I'm sure you can probably see from there that I would likewise get 0.5 on the other side, and I have 1 under the curve. On that technology, I can also do what's called numerical integration, and I might just quickly show how that is done. Switching to that calculator. Here's the deal here. So to do a numerical integration, you can see one that here's one I did earlier. I have a different function here. That's this one here. And to do that numerical integration, remember we had second function keys, the blue, and then hit another key to get to what comes up in blue. And on the alpha key, you would call up the alpha keyboard. There's also functions up here as well now, and if I go alpha, which is F2, you can see that I get a range of things here, and the fourth option is this integration. So that's where that comes from, and we can set up the integral. But it depends on the function being defined in here. I do hope to visit that again a little later. But for now, let's take a look. There's my histogram from the 2 dice, frequency histogram. And here's my segue to normal distribution. I was hoping to set up a live poll, but we didn't get the chance to do that. But my question, you can just shout out at your computer, is the distribution of the 2 dice, or the outcome from rolling 2 dice, is that a normal distribution? So we have a normal distribution on the right. You see the shape. Is the one on the left also a normal distribution? I'm hoping you're shouting no, because I'm hoping you remember that the one on the left is in fact a triangle. We just looked at that, did we not? Okay. The one on the left I created by putting random numbers into lists and adding them together. And the one on the right, I graphed this interesting looking function here, which I'm hoping you may have seen as the normal distribution, normal curve function. What do you think of that, Stephen? Was that a fairly clever sort of segue, or was it pretty clunky?
I reckon it's about as best as you've done there, Brian. Especially because everyone would have recognized that function sitting there. I mean, it's a pretty clunky function there that you can't integrate, at least analytically. So when it comes to numerical methods, that's the best you have. And the TI-84 also shows the shading there. So I mean, if you're a student and you're watching that, at least you have some sort of idea as to what's actually going on, because sometimes the maths can get quite intimidating.
Yes, and this is the one. Well, this is even in the further mathematics course as well.
That's right. Yeah. So.
Yep. So that's a good one there. Okay, the reason you've seen a lot of these for the TI-84, we said in the overview that we would address some use of that calculator and the Nspire. And I used a lot of this recently in a presentation in Adelaide, where that platform is used. They had some sample questions from the SACE, and I can't produce them for you here because that's copyright, but this is the essence. If we were looking at a situation that was normally distributed, you can see the mean of 37, standard deviation of 0.5. What then is the probability that a randomly selected value is greater than 38? Here is how I go about it. I graph this. That's not the only way to graph it, by the way. There is another shortcut. But I like this because it's showing you can see that in this I've got that mean value of 37 and I've got the standard deviation of 0.5 into the function, so students can see that happen. I just love the the connections of this and the visual. So here it is, and then we can do that shading as you saw me do on my previous slide. I can't go from 38 to infinity. I've gone from 38 to 39 and got, what, 2.27%. I then tried 38 to 40, but I had to change the scaling for that to happen. I've now got, what, 2.28%. So it's moved up a little. And it took a fair bit of messing with the window settings to get those pictures to happen. Much, much easier on Nspire. This screen capture is now from Nspire, Nspire CAS, and it can deal with infinity. And so that's just popped up into one of the wizards there, lower bound 38, upper infinity, and there's my mean and standard deviation. That's what it looks like on the execution. Similar things can be done with the good old TI-84. Look at this. It can't handle infinity. In fact, I challenge anyone who says they think they can. I just typed in, 10 to the 99. I thought that's close enough for all practical purposes. Is that the terminology? And you see pretty much the same results. There is, in fact, quite a menu of probability functions on that calculator. We can do the shading in the draw section, and that's how we got this to appear. And then it's a matter of doing that integration underneath. Okay, again, window settings can often take a little bit of practice. Here's the one that you got a preview of before. You see the function setup. We've got a fairly high degree, 7th degree polynomial there. We want to know the probability that our value is less than 1/2. I've defined it in the function editor. I graphed it. It's all over the place. As I said, 7th degree polynomial. I messed for quite a while to get window settings that would work. And then I thought, well, even though this thing is all over the place, I'm only interested in from 0 to 1. So I clipped it. And this is the clipping, restricting the domain. And now it looks like I've probably got it on better control on this, and I can do that shading. Just quickly, Stephen, I'll show how that is done on this machine. The function entered in the function editor, and you see my domain restriction here. These commands, the and, greater than, less than, come under the menu test. Here's our picture. Now, if I want to shade under that, there's a shortcut now, but remember the command calc. It's in blue here. If I go second on the trace key, and if I go for this 7th option, it looks like an integral. This is a non-CAS calculator, but by Jove, it's handy to be able to do this, isn't it? The lower limit, well, that was 0. And the upper limit, well, that was 1/2. The little yellow flashing light top right means the calculator is thinking, and there's our shading. I just love the visual of that sort of thing. And I showed you here how you could do the same sort of thing. We bring up this symbol, we put in our 0, we put in our 0.5. This is looking very much like an Nspire calculator at this stage, and we need to type, we could put the function in here. It's much easier if you've got the function set in the function editor, and I can access that by alpha and under the this one here, under the trace key. If you can't remember which one, just press any and then go left and right. That works. Isn't that handy? And number 1 is my y1 variable. That can also be found, by the way, accessing through the vars key. And there's our value. I just really like that. I've kind of rediscovered this calculator after spending the first half of my teaching career with it. The resources for this sort of thing, and particularly in Victoria, I know on the website under the student resource section, Peter Flynn has put in solutions not to the South Australian maths methods sample paper, but to the Victorian ones. So these are all for the VCE, Maths Methods and Specialist Maths. So different states have versions of these. Once again, I haven't got the copy of the question for you. That's copyright by the VCAA. But shall I say that in essence, there is a description of a binomial situation where there are 10 trials with an individual probability of success on a per trial of 0.26, and we want to know the probability that we get 6 or more successes. Oh, sorry, more than 6 successes. And so this is what this anonymous person put on the TI website for these solutions. And he's used a notes page, as you can see. And I'm just going to quickly show you how you can do the same without a notes page. That's the command here. Here's one I prepared earlier. To access this menu, statistics, distributions, you see binomial PDF is A on our list here. You see the arrow, there's more below that. Binomial CDF, cumulative density function. And our number of trials is 10. To move between the sections here, I press the Tab key in the window. And the probability of an individual success was 0.26. The lower bound was 6. And the upper bound, remembering there were 10 trials, will be 10. Isn't it nice we've got those little wizards that will guide you through? So I'm hoping that at this stage you will have explored those lists, but if you haven't, then make sure you do. And of course remember the website where you can download all those files. I think it comes across as an Adobe PDF file, all integrated into one, the entire papers. Here's another one. Sample paper number 2, multiple choice. It was presented as a multiple choice question. It isn't here. A sample of size 574 was described, and 76% of our sample is tested positive. We want to find an approximate 90% confidence interval for the population, of the population for positive. Here the results, and option B was described as the correct one. The trick here was to work out on a standard normal distribution, what our standard, what the standard deviation, sorry, what the standard how many standard deviations away we are from the mean. And this is what option B looked like, and this I have copied from the formula sheet that method students will have in their exam, so you can see where these values are placed in. I've done the calculation on the values up here, so I'm taking it a step further. And I also did a little picture of this, so using the Nspire calculator. So what I've done, I think this is worth emphasising to students. Here you have the probability distribution curve. This one is standard, so it's centred on 0 with a standard deviation of 1. So what it's saying is that if I go 1.65 standard deviations either side of the mean, I've got 90% of the distribution. Think about it. Remember, if we went one either side, we got, what, 65%? If we went 2 standard deviations either side, it was 95%. So it's fitting back into what we already knew about the standard distribution curve. But here's what I'd really like, and I think is an important connection. There's another one that I drew. Now, this is like saying that the percentage positive in our sample was 76, but I want to know with 90% confidence that for the entire population the percentage will be between what values, and I can say it's between the values 73.1% and 78.9%. So in order to do that, I had to calculate the standard deviation, which I did by working the Z-score formula backwards, and then I set that up in here. Just as another quick aside, and Stephen, I'm conscious of not wanting to cut into your time here, but just to show you how I did that, I set these up as functions first of all. There's my reworking for the Z-score. That was the Z-score for that distribution. And then I got the graph. So I'll just quickly show you what I did. I'll just insert a new problem here. So, okay, so on a calculator page, I set up, so let's say it's the normal distribution that I want to show. I'll go n of x is assigned to be, and here's the trick, go into the menu and go to the distributions, and what I want is a normal CDF, okay? Hang on, no I don't. Normal PDF. And the x value is x. That's the trick. So I make that the variable. Here you see I've got the mean and the standard deviation, and there it is defined. So now, if I go to a calculator page, so I add in the calculator page, and, sorry, not a calculator page, a graphs page, and I now graph that n of x. You can see that it is known, and there it is. So then it's a matter of messing with the Windows settings to get the nice type of picture that you saw back here. Okay. Just quickly, here's another handy one. This was a one-pointer, I think, on this paper. Sample size of 100, 60 positive, find an approximate 95% confidence interval. So it's the actual interval that we were to find. And this, once again, was set up in a notes page, and this is what it looked like on my calculator. I'll just quickly show you where I got that on the calculator. So here, and statistics, confidence intervals, and it was the 1 prop Z interval, and our successes was, I think it was at 60, and in 100, 95%, and there we go. So Stephen, I'm thinking that might be about time to hand over to you. There are more problems on here, but I don't want to steal too much of your time because I know you've got some wonderful things to share also, particularly with some more notes pages.
That's right. Are we good to go, Brian?
Yes, we are.
Excellent.
And I'll check on some of our chat and questions in the background. Thank you, Stephen.
Sure thing. All right. Can you see my my page, my screen properly, Brian?
Yes, I can.
Excellent. Well, thanks so much, everyone, again for tuning in, and thanks again, Brian, for that brilliant presentation there. There's certainly stuff there that I haven't seen before because I'm only used to the CX CAS. So all that stuff you did with the 84 CE was brilliant. So I'm sure the participants, especially those that used that calculator, really appreciated that insight. Yep. So we're looking at probability. Obviously, that's what we've been doing. So again, as Brian said, it's very ambitious what we've planned to do. But as a quick overview of what my section is, I've only got 3 main parts here. I've got binomial distribution, and I'm using a pre-made notes page for that. Also, a continuous random variables. I've got 2 pages for that, one with an actual example and another with an actual pre-made notes page. And I've also got a normal distribution with notes pages as well. As you can see at the bottom there, we've got the CX CAS on the left, which is what most of the attendees would, you attendees would be using in school. So I'll try to focus my presentation on that, but every now and then I'll switch over to the CX. And what I've done with my software is I've put the entire handheld there rather than just the keypad. So if you're ever looking at what I'm doing, just have a quick look at the left-hand side and look at the CX up there, or the CX CAS, and it should be clear what I'm doing. So I have made that available that way. So please feel free to chime in if you have any troubles identifying which calculator I'm using. So back to the presentation there. The first thing I'll be doing is looking at the binomial distribution. Now, anyone that knows Brian well at all knows that he's quite an avid golfer, and anyone he never turns down the opportunity to be talking about a nice game of golf, whether you're talking about a nice flat surface or a hilly one. So what I've got here is a quick sort of example that I've made up. Hopefully it's not similar to any VCAR or trial exams or anything, so I'm not infringing on any copyright, I hope. But I've just created this little question over here. It's at Studley Park Golf Course. So I did a bit of research before this webinar, trying to look for some golf courses that might pique Brian's interest. And the Studley Park Golf Course was the one that came to mind. So what we've got here is we've actually got a 9-hole course, and it has the unique feature that all the holes that it has are all par 3. which is brilliant because when you're looking at the binomial distribution, you want an independent and equal probability of each trial. So if all the holes are part 3, we can assume, at least in an approximate sense, in a first-order approximation, that the probability of a particular success on any of those holes would be equally likely. So taking those assumptions forward, I've said that on any part 3 hole, Brian's probability of getting a hole-in-one is 1/3, and then that each shot at a hole is independent of the other shots. So that's the sort of setup that we've got going. And the first question that we might be asked as well is, over the long term, how many hole-in-ones does Brian expect to achieve? So if a student looks at that question, hopefully they have a little voice in their head that's ringing a bell saying, hey, long term, expect, there's some keywords in there that are really shouting out, expectation or mean. So when you go to your calculator, I've got a binomial random variables notes page over here. Well, I'll just quickly run you through a little tour of what I've got here. This is what I call a pre-made notes page. So you take this page as it is, you transfer it to the students' handhelds, and if they need to do any sort of binomial calculations, at least any of the basic ones, as you can see, a collection of basic calculations, any of the basic ones, then they can open this file up, enter in their relevant parameters, and take it from there. It's by no means exhaustive of everything you would actually need, but at least for a basic understanding, and when you're starting this particular topic, it's a really good idea to have this on the students' calculators, and then they can actually work through that as it goes along. Obviously, it's not a substitute for by hand working, but when it comes to a lot of binomial problems where the numbers get quite big and clunky, having a tool like this is absolutely indispensable. Okay, so the first thing that this notes page has is it actually tells you what the binomial formula is at the top of here. So you can see PRX equals X equals NCX, P to the X, 1 minus P to the N minus X. Some students and some teachers might be familiar with the N choose X notation in terms of the 2 brackets there. Personally, I like the NCX. It's up to personal preference, really. So what I've done is when I made this file over here, and before I go any further, if you have any feedback about this file, about anything that you've seen over here, please feel free to leave that as feedback at the end of the session, or either that, or you can send through an email to myself at any time. And this file and all files that I'm showing during this presentation will be sent out to the participants as a link at some time in the near future. So this will be ready for you. I've made it. I've tested on both my handheld and computer, and I've ironed out any and all sort of bugs that have come up. So hopefully it should be good to go. If there are any problems, please let me know ASAP. Okay, so the first things, as the instructions say on the bottom here, is to enter the values of N and P below. So looking back at the question, we can see that the N value, which is the number of trials, is 9, because we've got a 9-hole course. So that means each I guess, hole, you can consider it as a trial, and then the probability of getting a hole-in-one is 1/3. So what we can do is go here, and then you can see I've got 8 1/5 because I was testing out with something else. But all you have to do is take it here, press the delete button. You might have to press it twice to get it there, and then press 9 and press enter. What that does is it now stores 9 into the value, into the pronumeral N, and then we can press down to get the 1/5, and then you can backspace that as well, and get control divide and 1/3, hit enter. So now what's happened is those particular parameters, which is N equals 9 and P equals 1/3, are actually saved into the calculator for all of problem 1. Just a quick reminder, if you want to see which problem you're in, you can just press the control button, as you can see here, and the up button. And what I've got here is all these 6 pages are all problem 1, so they're all linked. What that means is when I've got N and P defined over here, what is actually defined as, it's defined N and P in all the 6 pages. If I go to problem 2, which is this one at the bottom, which I'll hit soon, if you go to that one, that N and P value is not valid in that problem anymore. Okay, so now that we've got to that we've defined those parameters. You can go to the second page, and as you can see, it's gone and calculated the mean automatically. You don't have to do anything. As long as you define the NNP value in page 1.1, the mean will automatically be calculated and displayed appropriately in page 1.2. So that pretty much answers the part A. Over the long term, how many hole-in-ones does Brian expect to achieve? And that answer, as we've seen, is 3. By the way, this file over here, as you can see up there. Yes, you happy with that?
Oh, very happy.
That's
yes.
good. Am I overestimating your abilities there, Brian?
Just slightly, just a little.
Just slightly. Great to hear. Okay, so as you can see at the top there, this particular file is actually valid for both the CX and the CX-CAS because all the different commands that I've used in there are the exact same in both the calculators, which is brilliant because you don't have to go and modify these files at all. So that's the mean part done. Now for part B, it says find the probability, correct to 4 decimal places, that Brian achieves at least 7 hole-in-ones. So if you look at a question like that where you've got at least 7, then what you can do is press Control right. You can keep pressing Control right until you get to the page where you're looking at a sort of cumulative probability rather than a probability at one point. So as you can see on this page here, I've got x equals 2. So this is the page you would use if you want the probability of getting, for example, at least getting exactly 2 successes. So if Brian was to get exactly 2 hole-in-ones over that 9-course golf course, that would be approximately 23%.
I got more.
I beg your pardon?
I wouldn't be upset if I got more.
Oh, exactly right, yeah. So that's the probability of that one there. Let's go to the next page, and this is where we've got a probability of a range of successes. So if you're looking at the scenario where you're having between and including A and B successes, the between and including part is actually very important because binomial is a discrete random variable, it actually matters whether the endpoints are included. So this particular page assumes that you include both the endpoints. Now the good news is that the way I've made this page is we've got at least 7 hole-in-ones. So if you want to change either of those variables, if you look carefully at the bottom line here, as I change the numbers as A and B, it actually changes on there as well. So it even shows students the correct notation to write on their papers and not to write calculator syntax, as is the case with many students faltering and losing marks that way. So I've made this file in such a way that it gives you a lesser chance of making an error. So hopefully that helps the students if you do get to that stage. So the actual question we're trying to answer is when we want at least or at most successes. So the way I've defined this one here is I've only got one single pronumeral there, which is C, and in our case we can make it 7. So you want Brian having at least 7 hole-in-ones. So all you have to do is change that 5 to a 7, and then it updates both the probability. So depending on whether you want at least 7 or at most 7, and the one we want is at least 7, which is sitting here, which is 0.0082 or 83, as the case may be, because we want 4 decimal places. So as the students get practice with this particular file, they can get in their minds pretty well which page to go to. So they don't have to keep switching from 1.1 all the way to 1.6. They can just press the Control up, move over to 1.6, do the calculation, and move on to another question, etc. So that takes care of A and B for us. Quickly for part C, this is the one that sort of gets both teachers and students a bit nervous all the time. It's the one we have to solve for the sample size, and the algebra required in that tends to be a bit full on at times. So the example I've got here hopefully makes it a bit clearer. So we've got a special round in which Brian is allowed to have as many shots at holes as he likes, rather than just one, as we had assumed before. So what is the least amount of shots?
That's generally how I play. But I just keep following the ball from side to side.
That's right. So we want the least amount of shots that Brian is required to have a shot at, in order to achieve a greater than 80% chance of achieving more than 4 hole-in-ones. Now, if you write that as a probability statement, it's actually PRX greater than 4 is greater than 0.8 or 80%. The thing is with this particular command, this is actually a version 4.4 command. So if your calculators are not on 4.4, this particular page is actually not going to work because there's this brilliant new command on the calculators that's called inverse binom. And if you look over here, you can see inverse binom n. And that's a new feature of 4.4, and it was very good that they brought that in because it really made questions like this a lot more doable and a lot more achievable by the vast majority of students. So we want the probability of x less than or equal to 4. So you want the probability of at most 4 shots being less than 0.2. So we have to sort of reverse the statement initially, but you can do that quite easily without much issue. I just realized that that probably should have been an less than or equal to. So that's a little mistake that I made. Sorry about that. So going back to the actual file over there, we know that the probability of our particular success is 1/3. We want at most 4. So you can see PRX less than or equal to x. So I've even put a little tooltip over here to help you figure out what's going on. So you have the 4 sitting there already, and the other number at the bottom, as you can see, was 0.2. So click 0.2, and it tells you in a statement at least 19 trials are required. That means Brian will need to have at least 19 shots in this particular golf course in order to have a greater than 80% chance of having at least, or having more than 4 hole-in-ones. Not bad odds, are there, Brian?
Oh, look, 19's probably, yeah, getting close to what I'd take on a par 3.
There we go. And what I've also put in the file there as well is a little matrix that tells you on with 18 trials the probability of getting at most 4 is 0.231, and at 19 it drops below 0.2. So that matrix there actually shows you the stage at which the probability goes and changes. So I think that should be, that's exactly right, yeah. So that's a really good, nice feature of the version 4.4. So if you haven't updated to 4.4, please go ahead and do so ASAP. That feature is absolutely indispensable. So quickly moving on to the continuous distribution, I've got a very small, quick example of, I might run through this and my next stage quite quickly in the interest of time. So here's a continuous distribution example where we've got something quite similar to a past VCAR exam. It was actually exam 1 if I recall correctly. So we've got a continuous random variable, which is 1/6 times e to the negative x on 6 for all positive and 0x, and then 0 obviously otherwise. And we want m to be the median of x. So m is obviously the x value below which 50% of your probability is lying. So when it comes to this one here, I've got it set up in the notes page here as well. The first thing I want to do is actually identify approximately between what x values would we expect our median to be. So I've got a slider here with the integral between 0 and a particular value, let's call it a, and the slider currently is at 3. And as we can see, the cumulative probability from 0 to a is at 0.393. So if I grab that a value and slowly move it to the right, 3.5, 4, then 4.5, you'll notice that that number there, which is our cumulative probability, is in fact changing from 0.48 to 0.52. That means somewhere between 4 and 4.5 is going to be our median. Also notice that when the calculator graphed this, it's got the negative x, the inverse, sorry, the decaying exponential down there. And also on this left-hand side is the 0 function. This I notice with my students, a lot of them just tend to forget that over there. So this particular graphic here is a good reminder showing them that, look, that 0 function is actually important as well. He leaves it out and marks get lost. So moving on to some questions. So we want finding corrected 3 decimal places the value of m. So we know that at least in a CAS, we can just go to menu. I'll do it on the keypad itself. Menu, algebra, and solve. So our job is to solve a particular equation. That equation is then integral. Now we know that the integral is going to be shift and plus. There's a nice little shortcut. If you didn't know that, shift plus gets you integrals and shift minus gets you derivatives. So we know that the value of m, or the median, occurs when you go from negative infinity, tab to the value m. And we already have the function defined, so you can press the var key, press down and press F, and then X, close bracket, and tab along there, press X, tab again, equals, and 0.5, and we are solving for m. And you hit enter, and it comes up with this. And the problem with entering our initial function as a hybrid function is that sometimes integrals and solves don't work quite well. So unfortunately with this notes page, everything will have to be done in approximate form. Now, what happened there? There we go, m equals 4. So when I solved it approximately, I ended up with m equals 4.15. So as our conjecture had before, it was somewhere between 4 and 4.5 was our median, which is exactly what we're seeing over here. What I'll quickly do is switch over to the CX. So for those of you using the CX, the work is slightly different. Fortunately, the graph is still the same, so that's no problem. But when it comes to the when it comes to doing the actual calculation, the steps are a bit different. So I'm going to show you how it works there. So we're going to still go to menu, algebra, but the problem is now we have a numerical solve. We don't actually have we don't have the algebraic solve like we had last time. So you go to the numerical solve, and this time when you go for the integral, so I'm going to press shift plus again, we do the integral. If I try put negative infinity here, it won't work anymore. So unfortunately with the CX, we actually have to give it the numbers as required. Infinity is not going to work. I can either put 0, or I can put something as large as negative 10 to the power of 99, as you saw in Brian's 84 CE screenshot over there. But for simplicity, I'll just keep it 0 because we know that the endpoint of the exponential distribution in our particular example is 0. And then we can put the m at the top. You press our var f x, close bracket, tab x, tab equals 0.5 and comma m. And there, it solves it for us. So it's slightly different in the sense that we have to do an end solve rather than a solve. But I think it's very similar in terms of the CX and the CX CAS. So you obviously don't have the algebraic facilities of the CX CAS, but you still have numerical abilities over here, which is good enough for most situations. Okay, so what I might do is I might quickly skip over to the notes page of my continuous. I won't go through the whole thing over here, but basically we're looking at Brian's complete time, the total time for completing the whole course. I've got a particular random variable there between 1 and 4 hours, and it's that particular continuous random variable. And I'm just going to quickly take you through a tour of the notes page on that one. I'm showing you how it works. So here we've got the continuous. It looks, as you can see, it looks very similar to the binomial one. And all we have to do is just change the function that's sitting there. So it was 4 on 27. So I'll quickly just change that. 4 on 27, x minus 1 squared. X minus 1 squared, and I think that was 4 minus x, yes. And then I can change that 1 and 4. So all the student has to do when they see this file, they open it, it opens up to 1.1. They just have to go and change this. If they need to do a 3-set hybrid function, then by all means they can delete this entire thing and then press the template button there, and then they can use the 3-set hybrid function there. So that's certainly an option. but this particular example, as with most continuous distributions, we only need a two-set hybrid function. So once I've got that sitting there, then we can start moving through the different pages. And the first thing that the calculator actually does is it verifies that it is a valid probability density function. So as you can see, it actually asks, does the total probability sum to 1? And the calculator actually goes through the motions of evaluating the function between negative infinity and positive infinity, and we do get 1. So we know for a fact that this particular PDF, where is it? There we go. This particular PDF is indeed a valid PDF, and that's great to see. And then if the students want to calculate different probabilities, they can just go and change the different values here. As you can see, I changed the values of little a and little b here, and that changed it in here as well. So again, it shows them how they can write that on their papers. Unfortunately, the blue integral sign over there, that had to be with a and b in order to grab the numbers from the top there. But hopefully when they're writing it out, they can change those a and b values to 2 and 5 respectively. And you can see that the probability there is 8 over 9. So we wanted the probability between 2 and 3 hours. So if I change that b value to 3, we get the exact probability, which is 13 on 27. What is the next thing? Find the mean, standard deviation, and median. Now here's the great thing. If you want the mean, standard deviation, median, all that you have to do with this particular file is press Control right. It takes you to the mean. Control right takes you to the variance and standard deviation. Control right takes you to the median. And finally, Control right takes you to the mode. And that does it. And that's the whole file right there for the continuous thing. So for students that have trouble understanding all the different concepts behind it, the best they can do is simply go back to page 1.1, enter their function there, and just quickly move through all the different tabs, and they will see the relevant calculations and quantities, which is absolutely brilliant that the calculator does that automatically for you. I was meant to go through a quick normal distribution over here. Brian, are we able to do that, or do we have to call it quits now?
Yeah, we'll do a quick cover. That's I think people are really enjoying this and getting some good comments there. Yeah, and they know they're getting a very useful file from this at the end, which is good.
Yes, that's right. I'll make this all available, so you can definitely use this, play around with it. If you have any improvements, please let me know. That would be greatly appreciated. So I'll quickly go to the normal one, and again, as you can see at the top, it's the same for the CX and CX CAS. So rather than go through that example over there, I'll quickly just again take you through a little tour of this particular notes page. Again, we've got the PDF of the normal sitting there in case the students forget that. And as with the binomial, all they have to do is enter the value of mu and sigma. So I think the example I had was a mu of 10 and a standard deviation of 0.5. So we're now talking about how strong Brian's hits are for his golf swings, which is quite funny there. So I've got the 10 there, I've got the 0.5. That's it. All you have to do is change the 10 and 0.5. And again, as we take a tour through this page, it shows you the actual graph of the distribution. I guess it will make sense when you start finding areas under that, such as menu analyze graph, and we can do an integral, and we can choose 2 random x values and get a probability that way. You can even type in the x values if you'd like, and then we can do different ranges of measurements. So if you want between 9 and 10.5, if you want the probability that the hit is between then in terms of strength, you can change the A value to 9, change the B value to 10.5. And again, this updates as the A and B values update, and it gives you the probability with as many decimal places as possible as well. And then moving along there, we're looking at an inverse normal. So if we want the strengths, or the strengths that 90% of Brian's shots are, they look like they're about 10.64. So that, I think, covers everything that we had to go through. Hopefully I've covered as much as you need. And I'll send the files will be available for you to download. Please try them out in your calculators, and hopefully they're useful to both yourself and your students.
Terrific. Thank you very much, Stephen. And we're getting lots of thank yous coming through in the chat there as well. I think people are going to be looking forward to receiving those files, and particularly good to give to their students to equip them with for their exams. The dynamic notes is just an absolute winner. The fact that you can just have the page already prepared and then just adjust it on the fly.
That's exactly right.
Those people who were looking for operating system 4.4, here it is on the homepage, education.ti.com. You found your way to webinars, so presumably you found this page already. But the other one I will point out to you, student resources, and if you look under the Prepare for Exams section, you can state by state, these are the solutions I was talking to you about earlier, and for different states, here we have the TI-84 CE here. Yes, terrific. So a lot's covered there. Thank you once again to Stephen. You've obviously done a lot of preparation in putting those files together, and people will appreciate receiving those. And please, as you are leaving the webinar, pop in your feedback, and look forward to receiving your follow-up email, certificate, and to watch this again, either from the website or from YouTube. Good evening to all. Thank you to Stephen.
Thank you, Brian, and good evening to all as well.
And look forward to seeing you next time. Cheers.
All right, cheers.